Hello, welcome to today's lesson. Today we are going to look at parallelogram law of vectors. I'm your teacher, Edward. What is the law saying? But don't forget, before we talk about the parallelogram law, it is one of the laws that we use to find the resultant. We use the parallelogram law to find the resultant of two inclined vectors. You can use it to find the law, to find the resultant of two inclined vectors. So now let's go to the law. What is the law saying? So it has even stated here, two vectors acting at a point. These are the keywords I'm underlining. Can be represented in magnitude and direction by the adjacent sides of a parallelogram drawn from a point. Okay, drawn from a point. Then it says the resultant vector is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. So what does it mean? It means when you have two vectors given the direction and the magnitude, then these two vectors can represent the adjacent sides of a parallelogram. And if you want to find the resultant, then the diagonal of the parallelogram gives you the resultant. So let me throw more light on this law. But one important thing I want you to know is that let's look at this. Okay, so let's consider two vectors, V1 and V2, inclined, okay, at angle theta between them. Okay, where theta is less than 90 degrees. If theta is less than 90, then of course it is an acute angle. Okay, acute. Then if I want to apply the law, what is the law saying? It's saying that then if you have this V1, let's call this V1, let's call this V2. One thing which is not part of the law, but I have to pass here, is that when you are indicating the angle, there are two ways. You can either let it point towards, this is the point he's talking about. So you can let the angle point away, as I have done. So you see the vectors are pointing away from the common point here. They are pointing away. So you indicate your angle. Or you can indicate it this way. Towards. They can also point towards. This way. And theta. I hope it's clear. If you're sure, of course, you go here V1, V2. Any of them is acceptable. So you always indicate the angle by letting the vectors point towards, they must point towards the common point or point away from the common point. Then one thing I have to also tell you is that when they give you the angle between the two vectors, how do you draw the vector diagram? Let one vector lie horizontal. So you can let any of them lie horizontal. That is the reason why here I choose V1 to lie horizontal. Okay. So you can choose any of them. You can choose to V2 to also lie horizontal. Then V1 will go there up like that. So these are the two things you should take note. One is that the angle is shown by letting the vectors point away from the common point or point towards the common point like this. So any of them. The second rule is that because they gave you the two vectors and the angle between them, then you draw the vector diagram by making one of the vectors lie horizontal. Any of them. One of the vectors must lie horizontally. All right. So let me take the first case. We are looking at the case where the vectors are pointing away. Okay, then how do we apply the parallelogram law here? Don't forget, we need to form a parallelogram out of these 2 points, because according to the law, it's saying that you can represent 2 vectors by the adjacent sides. So these v1 and v2 are the adjacent sides. They are acting as adjacent sides of the parallelogram. Now, how do we complete a parallelogram from this? I need a parallel line, because for a parallelogram, this is how a parallelogram looks like. Okay. For a parallelogram, this side is parallel to this. This side is parallel to this. Another one important thing about parallelogram is that this side is equal to this side. This side is equal to this side. Parallel is not the same as equal, right? Okay. So back to the diagram. We need to get a parallel line to V1. And how do I get a parallel line to V1? So I can draw it this way. Let me see. Okay. So I will indicate the arrow and call here V1, because this side and this side are equal. Then I also need a parallel line to V2. I need a parallel line to this line. So I can do this. Can you see that? So you see I have formed my parallel line, okay? So I'll call here V2. So now I've gotten my parallelogram. Then according to the law is saying that, back to the law, is saying that we will get the resultant by the diagonal of the parallelogram, and it must be drawn from the same point. So let's go check the diagram. We are going to get the diagonal from the same point. This point is what he's talking about. Let me change the color of the pen so that you know what I'm talking about. He's saying that the resultant is the diagonal drawn from here. So what is the diagonal? I need a line to connect to these vectors. So this becomes my resultant. And because the V1 and the V2 are going up, the resultant will also meet this. Let me call this R. Will be my resultant. There is one important thing you should also know. One properties about parallelogram is that the adjacent angles, the angles here, the angle here and the angle here are supplementary, they add up to 180. So if you add the angle here and you add the angle here, you get 180 degrees. So of course, if here is theta, then this angle will give me 180 minus theta. I hope it's clear. Then how do I find the resultant? I can find the resultant now by applying the cosine rule. Check the triangle. The triangle. This triangle. I'm going to apply the cosine rule in this. Then I'll find the resultant. So using the cosine rule in the triangle. And what are we going to get? R squared equals what? V1 squared plus V2 squared minus 2V1 V2 cos of 180 minus theta. We have learned about cosine rule already, so you can visit my lessons. Go to my channel. One of the lessons I've treated cosine rule. So when you apply the cosine rule, then that is what you get. So from here, solving, you can now get the resultant, the magnitude of the resultant. Now, how do you get the direction? This same triangle, you see this triangle? Let me bring the triangle in the blue pen out. If I bring it out, I'll get something like this. Exactly. Don't change the position. Exactly as it is. Okay. So I'm getting something. Sorry. Here is 180 minus theta. The arrows must come. Don't leave the arrows. Okay. So you see, more like you've gotten it right. Okay. So what do you get? V1, V2, R. So you put your angle here. So in other words, you are putting this direction is what you are finding. The resultant, this is the resultant vector. So this angle, let's call it alpha. Okay. So if you transfer it here, then you can call here alpha. Then how do you get the direction? Here you apply the sine rule. And it's going to be what? Sine alpha over V2 sine 180 minus theta over R. So from here, you can get your direction. But don't forget here, our alpha is to the vector V2, vector V1. Our direction is to vector V1. Okay. So after finding your alpha, the direction will be what? Alpha degrees with vector V1. Or you can say that the direction is when you draw your cardinal point here. When you draw your cardinal points here, okay, then how do you get your direction? Your direction is going to be east, okay, alpha degrees north. So this is the first part of the parallelogram law. Now let's look at the case where they are not pointing. Check the diagram. We made it point away. What about if they are pointing towards? Okay. If V1 and V2. Somebody can also draw the vector diagram this way. If they are pointing towards. Don't forget, theta is still acute. Note. Let me write it here. Note. We are still using V1 and V2. Okay. Incline at what? Theta angle. At angle theta between them. Where theta is less than 90. We are still using that fact. But here, what I'm trying to do here is that I'm using the fact that, see, the iron, the one we've done so far, we were making it point away. The moment pointed towards, let it point towards. If it points towards, what do we do? If they are pointing towards, okay, theta. Use the same scenario. So this is V1, this is V2. Draw a parallel line to this. We need a parallel line to V1. We need so don't forget the arrows. This is of course this is V1. We need a parallel line to this. Okay, this is V2. Okay, then how do we get the resultant? We get the resultant according to the law, diagonal drawn from this point. Here, how is the arrow going to point? Check, V1 and V2 are going down, so your R will be this way. Remember also that for a parallelogram, this angle and this angle are supplementary. Okay. Anytime you have a parallelogram, let me draw it here and show you something. Anytime this angle and this angle they add up to 180. It is one of the properties of a parallelogram. Okay, so take notes. So if here is theta, of course, here will be 180 minus theta. So you apply the same cosine rule. Continue like that. Put your alpha here. So I'm not going to do that one again. So you put your alpha here. That will be your direction. Use the sine rule to find your direction. Then use the cosine rule in the triangle. Use the cosine rule in the triangle and you get what? R squared to be what? V1 squared plus V2 squared minus 2 V1 V2 cos of what? 180 minus theta. So that is that. After getting it, then you use the sine rule, you solve it and get your R. Use the sine rule to get your alpha. So you could see that, check the triangle. This is going to be the triangle. And when you find that direction too, it's still going to be, if this is your cardinal point, it's still going to be east alpha degrees north. If you draw it out just like what we did here, you get the same angle as we did previously. I hope you are following. So all these ones, we are looking at the case. This is case 1. Okay. Now let's look at case 2. What we've looked for so far is for case 1. Look for case 2. Case 2, we are considering when it is obtuse. Consider V1 and V2, okay? Consider vectors, okay? V1 and V2 incline at angle let's say beta. Let me still use theta, okay? Angle theta. Should I change the value? Okay, angle alpha. I've already used alpha, so let me use beta. Where, okay, where beta is greater than 90. But less than 180. That is beta is between 180 and what? 90. So how do we represent it? 90 degrees less than this. That is how you write it. It means it lies between 90 and 180. And this type of angle, we call it obtuse. So here we are looking at the case where the angle is what? Obtuse. I don't know. Let me write it so that you can see. Obtuse angle. So if it is obtuse, how do you draw it? For example, they give you value like 120, 110, 130, 150. All these are greater than 90. So you see, you can't draw it by showing the angle. Such question, you can't draw it by doing this. Because this angle is not obtuse. This is still acute. Okay. So if it is obtuse, then you have to draw it something like this. I hope you are following. Yes. So just like I said previously, because they gave you the two angles, the angle between the two vectors, draw by letting one lie horizontal. Let one lie horizontally. So that is what I have done. And you can indicate the angle by doing what? Making it point away from it, or making it point what? Towards. Any of them is acceptable. Okay, so assuming we choose this one, V1, V2, incline at angle, we said beta, so let me use beta. Then according to the parallelogram law, we need a parallel line to V1. How do we get a parallel line to V1? There's a parallel line to V1 I'm drawing. We need a parallel line to V2. This is V2. Check V2 is this. So we need a parallel line to V2, and that is this. Okay. Don't forget they are parallel, so you must indicate it. V1, this one is going down, V2. Then of course this angle and this angle are supplementary. They add up to 180. So here will be 180 minus what? Beta. Then according to the parallelogram law, what will be the resultant vector? The resultant vector will be the diagonal of the parallelogram drawn from the point. Which point? The original point. This was the original point. So you draw the diagonal from here. Take note of the law. So from here, connect it to this. Check the arrow. They are pointing towards the point. The V1 and the V2 are moving towards the point. So your resultant must also move towards the point. So this will be your R. I hope it's clear. Okay. Now what do? You apply the cosine rule. So using the cosine rule in the triangle. Okay. Which of the triangles? We are talking about this triangle. Okay, this triangle is where we are applying the cosine rule. Okay. And if you are applying the cosine rule there, what do you get? Get r squared. Let's do it before. R squared equals what? V1 squared plus V2 squared minus 2V1 V2 cos of what? 180 minus beta. I hope it's clear. Then how do you get the direction? The direction, of course, should be this. Let's call it alpha. So let alpha be the direction to the vector, to the direction of the resultant. Let me put it that way. Of the resultant to vector V1. Okay, that is it. So that when you are applying the sine rule in the same triangle, this triangle is where we are applying the sine rule, you can use it to solve your alpha. Okay, so when you use the sine rule, using the sine rule, and what do you get? Get sine alpha over V2 is equal to what? Sine 180 minus this angle over R. Sine 180 minus beta over what? R. So from here you get your angle. And when you finish getting your angle, how do you state your direction? The direction is alpha degrees with vector v1, or you can say that the direction is east alpha degrees. Okay, because if you draw the triangle, check it. Check the triangle. When you bring the triangle out, this is the triangle I'm talking about. Let me change the marker. If you bring the triangle out, it's going to be something like this. Okay. V2, V1, R. Yes, alpha. Okay. So when you solve for alpha, then you can see east alpha degrees what? North. East. So for the direction, there are so many ways you can state it. Because if the question is not specific, somebody can even choose to find it to vector. Somebody can also put the direction here to vector v2. So that one doesn't change anything. So we call this one the parallelogram law. I want to give you this trial example to try. How do you apply I want you to apply the parallelogram law of vectors to the vector diagram below. And I want you to use R as the magnitude of the resultant vector. Okay? And this is the diagram. This time around, let me do something like this. I want to check, I want to test your understanding. Okay. I'm calling this F1. F2. And let me see the angle between this and this. Let me call this angle the angle here. Okay, let me use theta. Okay, so apply the parallelogram law. Just complete the diagram for me. Okay, I'll be looking for your comments. All right, so let's end today's one here. See you in the next lesson for one question on this law. If you have not subscribed, don't forget to subscribe. Goodbye.